So the first type is solving the equation. Your goal of these is to get rid of your root. You do have to find the answer and then make sure the answer works for these, i.e. extraneous solutions. So for this first one, we're just gonna, my radical is already by itself, which is what I want. So I am just gonna square both sides to get rid of my radical. So I am going to take both sides here, square that side, square this side. On the left, I'll have k squared. On the right, my root just goes away. When I have something like this, I want to move everything to one side and get it equal to 0. So I'm going to add my 4 and subtract my 5k over. So I have k minus 5k plus 4 equals 0. So once I have the root gone, I want to get it set it equal to 0. If I have a squared. If you have just an x or something like that, just solve for x. But this is how you solve for x. So this is something that's very easily factorable. Factors of 4 that add up to 5. That's 1 and 4. So I'm going to say k minus 1, k minus 4. Why do I know it's minus minus? Why do I know that?
Because it's negative 5.
Right, because I need to multiply to get a positive 4. So they have to be the same sign. And I have to add to get a negative 5. So they both have to be negative, all right? So that means my possible answers here are going to be what makes that 0. So positive 1. So k is going to either equal positive 1 or positive 4. I need to go back and make sure they both work, okay? So that is my checking. I need to see if these work. So I'm going to say, well, let's plug in a 1. 1 equals the square root of negative 4 plus 5 times 1. Negative 4 plus 5 is just 1. 1 equals the square root of 1. That is true. So I know that my 1 works. Plug in a 4. Square root of negative 4 plus 5 times 4. 5 times 4 is 20. 20 plus negative 4 is 16. 4 is the square root of 16. That is also true. So I know that both of those work. I want to point something out here. Had this been a negative number, like had one of them been negative, and even if it, so let's say we got negative 4 was one of our answers, and that equals the square root of 16, that would not be true. All right, so if you plug it back in and it says negative 4 equals the square root of 16, that is not true. The only time you do a positive and negative root is if you're saying x squared equals 9. Well, then that's positive and negative 3. All right, but when you're just saying, if I just said, hey, what's the square root of 16? You would say, well, that's 4. You wouldn't say negative 4. So we're looking for primary roots here when you plug it back in, order of operations. We're not talking about solving into an x squared and considering the positive and negative root. That's when you have a variable that you're solving for. I just want to point that out because that's something that I see missed on quizzes and tests all the time, is when it's a negative number and they think it works. So determine the real zeros. Well, that's just where the function equals 0. So I'm actually going to set this function equal to 0. And I'm going to see what x's make that possible. I'm going to factor it. The first thing I do in factoring is look to see if something can come out of every single term. And x can come out of every single term. So I'm going to say x squared minus 4x plus 4. Factors of 4 that add up to 4, that is 2. So this is going to be x minus 2, x minus 2. That means that this is 0 when this one is 0, which is 0. That one, and that one, which means my zeros are at 0 and 2 with a multiplicity of 2. All right, so for this one, you have your even and odd. That is your degree, if your degree is even or odd. And then you have your coefficient, which can be positive or negative. Even means they go the same direction. So it's even and positive, then as it's going to be, you know, the graph that looks like this. Even and negative is going to be the graph that looks like this. Odd and positive is going to be like that. And odd and negative is going to be like that. However, I want these in limit form. So you'll notice your answer's in limit form. So what does that mean? Well, that means that when it looks like this, then the limit as x goes to the left, as x approaches negative infinity. So as x goes left, it's going to be going up. The y is going up. And as x goes to the right, it's also going to be going up. So you have to know how to decipher these graphs as well. So if I were going to do this one, well, then the limit as x is going to the left is down. And the limit as x is going to the right is down. All right, so you have to know how to write these in the format of limit theory. Limit as x is going to the left is down. Limit as x is going to the right is up. And then the last guy, limit as x is going to the left is up, and limit as x is going to the right is down. All right, so you need to know how to tell me that in limit form. So this particular guy, well, he is even or odd. Well, that is even, right? And then positive or negative, well, that is negative, all right? So he's going to be even and negative, which is this guy right here, all right? So I'm going to say then my limit as x is going left, well, that's going to be down. And my limit as x is going right is also going to be down. And so that would be my answer here. You can divide either way. I don't care. If you divide synthetically, remember if you have a coefficient on that x, you need to divide at the end by it, okay? So if you do your synthetic when you have a coefficient in front of that x, then you definitely want to remember to divide at the end, everything except your remainder. So if it's this way, you can just do synthetic without a problem. Or you can always do long division. It does not matter. I don't make you do it one way or the other. Right, so whatever makes this 0 is what you're going to divide by. And that's true if there's a coefficient or not.
Yeah, and
so for this one,
the 3 in front of it, you divide everything by 3.
I do want to point, for this one, I do want to point something else out. 4, 3, 2. We're missing 1, so you have to put a 0 there. And so I just want to make sure y'all remember that piece of it, because that is also a very common mistake. The answer here is going to be this entire, actually when you do this one, you're going to have to put your x's back in as well, because you want to make sure. All right, try again. -8, there we go. -8, positive 32, -4. Which one did I choose? 4. Okay. And then you do have to plug in your x's. So it's 5x, go 1 down from here, cubed minus x squared plus 2x minus 8. This guy should be over your divisor here. So for this one, keep whatever it is the way it is. It says k equals -4, use -4. The difference for synthetic substitution is only the remainder is your answer. If you give me the entire thing, you will miss points, okay? Just box that remainder, that is your answer. So you're gonna do this exactly the same. Again, 3, 2, 1, and you have to have a constant here. So when you do this, you do have to add a +0 for the constant. You must have every single variable and a constant when you divide, all right? So even if you're missing it at the end, add that 0 at the end if they did not give you a constant. So for this one, you would do 3, 21, 30, 0. You'd have to add a 0 there. And then your remainder, whatever you get right here, that is your answer. That is your only answer. Synthetic substitution, your answer is your remainder. You are dividing here. Again, you can divide either way. I do not care how you divide. You can divide long division or synthetic, all right? What we are checking here is the remainder, but the remainder is not our answer. If our remainder is 0, then the answer is going to be yes, it is a factor. if the remainder is not 0, anything but 0, it is not a factor. It would be no, it is not a factor. Okay? So again, this division is going to be dividing, synthetic substitution, and remainder. Like all three of these have to do with division. So make sure you know how to do division, either long division or synthetic. Or, yeah. So either way. I do not tell you to do it one way or the other. But all three of these questions, you're going to do divisions for. So for this one, you are just going to have to do the real, the possible number of positive and negative, possible rational, and then find the zeros, and I will give you a 0. Okay? So, and I have all the answers there. All right, so if I want to know the possible number of real zeros, yeah, it's going to be 3 because that is my degree. For the positive and negative, I am going to use my Descartes rule of signs here. So for positive, I'm just going to say this is positive, so we don't count it. This is positive, so no. This is positive, this is negative, so that would be 1. So number of positive potentially is going to be 1. And then I'm going to do the same thing if I were to plug in a negative here. So if I were to plug in a negative here, this would become a negative. If I were to plug in a negative here, this would stay a positive. If I were to plug in a negative here, that would change to negative. And this guy will stay the same because he has no x value there. And then I'm going to count again. Negative to positive, that's 1. Positive to negative, that's 1. Negative to negative, no. So the number of negative is going to be 2.
What?
And your answer key goes down by 2 because they pair up, but I only make you list the highest number of negative there. And then it wants me to list all the possible. So all possible rational. Well, that is going to take that last number over the factors of the first number. So the last number really only has 2 factors, 1 and 5, right? So positive and negative 1, positive and negative 5. This guy only has 2 factors, 1 and 5. So I put these over 1. Well, that's 1 over 1, 5 over 1. We're good. Now I put those same 2 over 5. So that's going to be positive or negative 1/5. But 5 over 5 is just 1. And I already have 1. So that's all my possible right there. That's all my possible. And then the last step is to find my zeros, and 1 has been given. So they gave me this -5 here. So my zeros, I can actually go ahead and write down -5 because they told me, right? So that's nice. And then I'm going to use synthetic division to calculate the rest of them. So I'm going to say 5. Again, you need to make sure it goes cubed, squared, 1, nothing. So, and then we're going to do our synthetic division. By the way, if you do the synthetic division and you get something other than 0 for your remainder, you did something wrong because they just told you that that is a 0. So if you do not get a 0, you did something wrong in your synthetic division. So this guy is 5x squared plus 4x minus 1. You want to see where that's equal to 0. You can either solve this by factoring or by the quadratic formula. I do not care which way you solve it, okay? Either way, you should get, I mean, when you do your factoring or when you do your quadratic, you're going to get this factoring here. If you do the quadratic formula, you're going to get the same answers, but you're going to get 1/5 and -1 here. So whether you do it by factoring or quadratic formula, you're going to get the same answer, okay? And so my zeros here are going to be 1/5, -1. So you can do this using this guy. So first of all, your square roots and your i's always come in pairs, okay? So if it's a square root, square root of 3, you also have to assume negative square root of 3. If it's 2i, you have to assume negative 2i, okay? They always come in pairs, all right? It's always x minus this number. So x minus a negative 2. So I'm going to put plus 2 there. You know this is correct because negative 2 would make this 0, and that's what you want, all right? X minus square root of 3, and of course x minus the negative square root of 3, so x plus square root of 3. Always going to come in pairs when it is a root or an imaginary, okay? When I do this, I will always do my pairs first when I FOIL, because it is going to work out to be just the first one squared minus the second one squared. It's a special case, so I don't have to go through the FOILing process. I can take the x and I can square it, always subtract, and then I can square a square root of 3. What is the square root of 3 squared?
3.
3. And so that's a really easy FOILing. So always do your pairs first. Always do your pairs first.
That was really so easy.
All right, and so then at this point, you're just going to FOIL. So x times x squared, x times negative 3, 2 times x squared, 2 times negative 3. Yeah, put them in order because I don't like that. But x cubed plus 2x squared minus 3x minus 6.
Hello, what sign do you flip?
I always start with the y-intercept because I can do it right here without doing anything else. And I do the horizontal because I don't have to factor anything to do that. So I always start with my y-intercept. That is if I make all of these x's 0. So that means it's going to be 0, 0, and I'm just going to have these 2 on the end. I will tell you, some of y'all missed this because you just did the numerator or you didn't pull your negatives with it. So this is going to be everything 0 except my constant. So this is going to be negative 8 over negative 24, okay? Which reduces to 1/3. So that is my y-intercept, positive 1/3, and I'm just going to put that right on my y-axis there. All right. I can also do my horizontal asymptotes here because that is my shortcut. And so if I go ahead and do my horizontal, I just look at my degrees, all right? If the degrees are the same, then you use your coefficients. That's a 1 right here over a negative 3. So my horizontal is going to be the line, the y equals negative 1/3. Negative 1/3. And so then I can go straight to negative 1/3, and I can draw that dashed line there. All right. And so I'm going to take my equation, and I'm going to factor this out. The top, factors of 8. Let's subtract to give me 2.
That would be 6 and 2.
So 4 and 2, right? X plus 4. X minus 2. On the bottom, you can actually take out a negative 3. You have x squared minus 6x plus 8. All right. And so you can take that negative 3 out. Factors of 8 that add up to 6. That's 4 and 2, right? So x minus 4, x minus 2. All right, so at this point, I can look at my holes, my vertical asymptotes, and then at the end, I'm going to look at my x-intercepts, all right? And so if I look at my holes, that is going to be what makes the denominator 0 and cancels. Cancels, yeah. So these are the guy that cancels. So my hole is going to be at positive 2, what makes it 0. I'm going to have a hole at 2. I'm going to have a hole at x equals 2. And then to find out what my y value is, like where I would actually do that, I can plug 2 into the rest of it. So I can say 2 plus 4 over negative 3, 2 minus 4. I'm just trying to figure out where I'm going to graph this guy. So that's going to be at 6 over negative, what was it, negative 6? No, that's going to be positive 6. So it's going to be at 1. So at 2, 1, I'm going to have a hole. I'm going to have a hole in my graph. So to find the y value, you just plug it into what's left over after you cancel out your hole. So I just plugged it in. All right, for my vertical asymptote, that is what makes the bottom 0 but does not cancel. What makes the bottom 0 but does not cancel, okay? And that is going to be just 4. And so I can go to positive 4. And then I want to draw my vertical here. What makes the denominator 0 but does not cancel out? That's this guy right here, okay? That guy right there. And then the last thing they're asking for is my y-intercept. My y-intercept now at this point is what makes the numerator 0 but has not canceled out. So what makes the numerator 0 but is not canceled out? That is going to be negative 4. Negative 4. So my x, not my y-intercept. Did I write y? That's x-intercept. Sorry. X-intercept. So it's going to be negative 4, 0. What makes my numerator 0 but not? And so I'm going to go to negative 4 here. And I'm going to put it on the x-axis, x-intercept. So it's really clear what's happening here, right? We have this curve that's going like this. All right, so that's pretty obvious what's happening up here. What about on the other side? I do need to draw over here. Is it going to be in the top or the bottom, that curve that's going to form?
Bottom.
Why is it going to be in the bottom? I have exhausted my x-intercepts, correct? If it was over here and it gets infinitely close to this blue line that is below the x-axis, would it not have to cross the x-axis to get there? It would. If it crosses the x-axis, I should have another x-intercept somewhere over here. I do not. It cannot cross the x-axis again, so I know that it's going to have to be over here. And so you can sketch some curve. Now you can test a point. Let's say you're not sure. You can pick 5 or 6 and you can go back up to your original function and see if it's positive or negative, to see if it's up here or down here. All right? But logic tells me I cannot cross this guy again, so I'm likely not going to have it in the numerator there, or in the top, sorry. All right, so the key to this is to multiply everything by your common denominator. So the first thing you want to do is find your common denominator. This is already factored, so he is just v minus 3. This factors to what? Factors of 6 that add up to negative 1. V minus 3, v plus 2. Okay? And so I'm going to take that whole thing and I'm going to multiply it by my common denominator. So I'm going to say v minus 2 over v minus 3 equals 1 plus 4v plus 24. All over, I'm going to write this as v minus 3v plus 2 because that's what it is. And I'm going to multiply every single piece of it by that v minus 3, v minus 2, plus 2, sorry, v minus 3, v plus 2, all right? Then I'm going to cancel what I can cancel. This first one, I can cancel the v minus 3. So I have v plus 2, v minus 2. Cannot cancel anything here. So I just have v minus 3, v plus 2. And then here the whole thing cancels. So I just have 4v plus 24. FOIL, this is a plus minus. So this is just going to be v squared minus 4. FOIL here, v squared plus 2v minus 3v minus 6 plus 4v plus 24. In this case, move everything to one side. Okay, move everything to one side and combine your like terms. So I'm going to move this over and it's actually going to cancel, right? It's going to cancel on both sides.
Oh, this was.
I'm going to move my 4 over. So what I'm left with is 2v minus 3v, which is -1, plus 4. That gives me 3v, right? And I have -6 plus 24 plus 4. So what do I have? Hopefully I have 22, right? And all that equals 0, right? How do I solve this? I have 3v plus 22 equals 0. How do I solve it? Yeah, subtract my 22 and then divide by 3. So v equals -22 over 3. You do have to check these for extraneous solutions, but really the only thing you're checking is, will it make my denominator 0? Well, what makes this 0? 3. What makes this 0? 3 or -2? Are any of my answers 3 or -2? No, so that is my answer. It's not extraneous. If I had gotten 3 and 4 as answers, 3 would be extraneous, 4 would be a solution. But -22 over 3, while it's a hideous answer, it's not extraneous.